Hello and welcome to our 6 key ingredients of a successful Pythonista training. I'm Bob Beldebos, co-founder of Pybites, and I'm excited to show you today how to write cleaner and more Pythonic code. So first, I will go through some common issues I highlight in code reviews we do for our clients or anytime I review some Python code. And I will top it off with 5 ways to write more Pythonic code. I hope you're as excited as I am to learn this stuff, so let's dive straight in. One of the things that I often highlight is too much code into functions or methods or classes, whatever it is. You have to start decoupling your code because too much logic in one place makes it hard to reuse things and it makes it hard to test. So here in this main methods, there's a lot of stuff going on. It's printing, logic calculations, break it out into multiple functions and your code will be easier to maintain. Reinventing the wheel. In this snippet here on the right, we see URL parse and a lot of stuff going on with handling that request. Well, you can, and yes, it's a dependency, but you can pip install request, and that makes it probably a few lines of code because that library already is very good at handling HTTP requests. So you just cannot go wrong with that highly maintained and tested library. So in some cases, use the tool that's best for the job and don't reinvent the wheel. Constants. I often see magic numbers in code like this 1 and 4, and you're not really sure what does that mean? Like what are those boundaries? So it's very easy to set those to meaningful names to some constants you define at the top of your script, and it makes your code more usable, reusable, but also more readable. It's all about, like, writing code is partly communication, and this is really telling the other developers what you mean with your code, or as the Zen of Python says, explicit is better than implicit. The global scope, that's really a pitfall. Like in code, a lot is about encapsulation and protection against other people overriding or changing the state of your code. So all this stuff in this example is happening in the main body of the code. So it's very easy to wrap this into a class or a function, which then limits the scope. It takes it out of the global scope into a local scope, which is more secure and leads to less surprises down the road. Code style. So here on the left, we see a whole bunch of logic wrapped into a list comprehension, which is fine, but it's all in one line, which makes it harder to read. So it would be very easy to break it out over multiple lines, and you could do that manually and using Flake 8 to check that your line length is within a certain range, which is 79, but you can expand that in your settings. Or you can use an auto formatter like Black to automatically have your code formatted. And on the right, we see the imports of the standard library and external packages mashed together. And as per PEP 8, which is the coding standard for Python, you should break up your dependencies in standard library, third-party packages, and then your own libraries. And it's a little detail, but these small things matter in how readable your code is and how you come off as a professional developer. Duplicated code, that's kind of the greatest sin in coding. Like anytime you duplicate code, you're inevitably going to forget to update one of your copies. So anytime you see duplicated code, just abstract it out into a separate function or class and make sure your code is dry or don't repeat yourself. Every piece of logic should live in one place. Exception handling. In this example, there are like 20-ish lines between the try and except block. And no way that all these 20 lines are going to raise that exception. Like a time sleep is not going to trigger an exception. So make your exceptions very explicit around the specific lines of code that can raise that exception, which in this case are probably 2 or 3. And also here, well, at least exception is named as the possible exception because all the exceptions inherit from exception. So the uppercase exception here is what's going to be hit, but it's better to be more explicit in what exception we're dealing with here. So it could be a value error or a type error or whatever, but exception is kind of the catch-all. So again, the more explicit you can be in your code, the better. And Pythonic code. So in this example, this was a great opportunity to use a with statement. So if you do a try, except, possibly an else, and finally, the try finally, it's more Pythonic to use a with statement, which is designed to clean up resources once you go outside of that with block. So knowing the Python concepts and the language well goes a long way. Another example is applying the same logic to a lot of functions and doing that over and over again. Well, maybe you should abstract it in a class, or maybe use the decorator pattern, or write a decorator and apply that decorator to multiple functions. Again, knowing the language inside out goes a long way and will make your code more concise and easier to work with. Another red flag is if you have a lot of indenting in your code and a lot of what's called cyclomatic complexity, which is the amount of if and else, basically the amount of decisions in your code. Because if I would have to test this get similarities function, I would have to have full test coverage. I would have to test all these branches, and there's a lot. So in this case, I recommended to simplify this function, breaking it out in multiple functions to get rid of this indenting. And so it's probably a signal that the function is doing too many things. So again, if you're seeing a lot of indenting and a lot of if-elses, that's complexity right there, and you should simplify that to make your code more maintainable. And that's it for some tips I commonly highlight in my code reviewing to clients or fellow developers. Now, lastly, I wanted to show some Pythonic code. I mean, we can do hundreds of tips there, but I just picked a few which I randomly use and which are really elegant. So let me share that now. So I'm going to go in my Python REPL. And first I'm going to show you how to make a dictionary of two sequences. So if you have some names, I can make a list by splitting on white space. And I got a bunch of scores. And notice that's one less than the names, but I will get back to that. And then we can use the built-in zip to zip the names with the scores. And what's going to do is going to pick one name and one score sequentially. This gets a lazy object. So to consume it, I can put in a list. And effectively, Sarah was paired with 22, Ed was paired with 33, Julian was paired with the next score, which was 44, and Tim was paired with 55. And Fernando was not paired at all because the scores list, or tuple in this case, ran out of items, so it got truncated. A little trick to go beyond that is to do from iter tools import zip longest. And then we can do the same thing. And Fernando gets included, but none, because there's not a score. But at least it recognizes that Fernando should be in the new sequence. Now, instead of a list, we can pass this into the dict object creator or constructor. And now this is a dictionary. So that's awesome. I got two sequences, zip pairs them together, and then we pass it into dict, and you have a dictionary. Very useful technique. Another one is enumerate. So if you want to loop over the names, but we also want to keep track of the index, the position in the list, like in C, you would have to probably start your counter, keep track of the counter in the loop, and print that counter separately. In Python, you can do that in one go. So if you to loop over names, first of all, is for name and names, print name. Probably no surprises there. If I also want to have the position, I can wrap names in enumerate. And we get the index as well. If I want that index to start at 1, well, I can give enumerate the optional argument of start, starting at 1. And of course, I need to bounce that. I need to enumerate then gives me two variables in the loop. So the counter and the name. And then it starts at 1. Actually here, by giving here one variable in the loop, I was actually assigning that tuple to name. That's why we got a tuple here. So if you want to have those variables separately, you do it like this. So E is for the counter, name is for the loop variable, and here I print them both. And I started one thanks to this optional argument. Another one is sorting. So I can sort name, let's say that dictionary we had before, to make it a bit more interesting. So let's save this to user scores. That's now that dictionary. And by default, it's going to, if I use sorted, it's going to, and that's on the keys. I want to do it on the items. It's going to sort by name, right? But what if I want to sort by scores? Then I can give sorted an optional keyword argument, and I can say lambda, which is an inline function. For every element, take the, so if I use sorted, it gives me a list of tuples. Every tuple has two elements, the name and the score. By saying key lambda x x1, because indexing starts at 0, I'm effectively saying the sorting algorithm to take the second element of each tuple. Now this is failing because none is not an integer. So let's get rid of this for none no guy for a second. And do this again. And now the user scores are sorted not by name, but by their scores. Lambdas are fine. Syntactically, I like operator a bit better. So from the operator module, I mean, and specifically item getter. So I can replace this with item getter. So the key argument here takes any callable, right? So this is the same, but it's a bit more elegant. I could also sort it by the length of the name, which is odd. Yeah, a better example is to just sort that on the keys. So by default, again, it sorts on alphabetical order. But if I use the length, it's going to sort it by the length of the name. So 2 characters, 3 characters, 5 characters, 6 characters. So yeah, key is very powerful to sort your sequences in a customized manner. Another one is f strings. So say I want to, like in that previous example of the enumerate, I want to do some formatting here. For some reason, I want to say the number, and then a dot, and then the name, and something else. Well, this works for now. I'm so used to f strings that I'm already messing this up. So the old way was to use format and then just gives those placeholders, which get interpolated. But now with starting Python 3.6, we can actually get rid of this and embed or interpolate the variables straight into an f string. Yeah, so f strings are the way to go. It's shorter, it's faster, and it's very Pythonic code. Lastly, a counter from the collections module. So if I do from collections, and you really want to study collections module, awesome module, some really great data structures in there. But let's do some counting of words, of most common words. So say I have this text, which I already prepared. And I can make a multi-line text with triple quotes. And I can make that into a bag of words by doing a split on new line. So now we have a bunch of words, and I can, like, if you want to know the most common words here, right? How would you do that? You would initialize a dictionary, start to keep track of every word in the dictionary and count them, how many times they occur. Well, there's a class for that, counter, and if I pass that in words, it does it for me. So it creates me a special counter object, which is kind of a dictionary, but it shows the most common words first. And if I just want those most common ones, I can say most common 5, and not surprisingly, all these stop words and to are the most common. But so is Python, which is kind of cool. Well, and congruent with the fact that we're doing Python training and coaching. So yeah, a lot of manual processing or calculation is taken out by just, again, not reinventing the wheel. So those are just 5 tips. We have a book with 250 tips, which goes much more in depth, taking Python inside out. But yeah, this is just to show that, yeah, writing Python well, it's very elegant, it's very beautiful language, and your code will be more concise, more readable, and more reusable. Hey, it's Bob again. I hope you enjoyed that training, that you got a lot of value out of it, that you got itchy fingers to write Python and to adopt those principles and learn more and make your code cleaner. This wraps up the first day of our training, and tomorrow I will be back and I will teach you about how to start a Python project and how to use Git and GitHub, because we are not living in isolation. We have to share our code with other developers, and Git is the currency through which you will do that, Git and GitHub. So see you tomorrow with another training. Thanks for watching.